Welcome to Byte Sized AI. I'm Michael Barnes, and honestly, folks, I've got a feeling today's topic is going to hit home for a lot of you, especially if you're trying to build anything in the tech space recently, or even just buy a new gadget. We're diving deep into something we're calling Ramagedon, this really intense AI-driven memory crunch that's got the entire industry in a chokehold. It feels like big tech's bottomless money pits are just sucking up all the oxygen, squeezing out smaller companies when it comes to critical components like GPUs, cloud access, RAM, and even SSDs. We're hearing wild stories about refurbishers literally scavenging old laptops just for their memory, SD card makers pulling back from the consumer market, and prices for pretty much everything just skyrocketing. It's a mess, to put it mildly. And to help us unpack all of this, to give us those fair technical answers we so desperately need, I'm thrilled to welcome Randy to the show. Randy, thanks for joining us. Let's not beat around the bush. For those who are hearing Ramagedon for the first time, what exactly is it?
Thanks for having me, Michael. It's a pleasure. You've really set the stage perfectly. Ramageddon is essentially the looming global memory shortage. Specifically, at its core, it's about AI data centers. They are just devouring memory at an unprecedented rate, particularly DRAM, and even more specifically, HBM. That's high bandwidth stacked memory. It's the incredibly specialized high performance memory designed to work hand in glove with GPUs, which are, as we know, the workhorses of AI training and inference. The big three memory makers globally, Samsung, SK Hynix, and Micron, they've all pivoted. They've shifted their manufacturing capacity, their silicon wafers, away from producing more standard consumer-grade memory like DDR5 for your average PC or NAND flash for your SSDs, towards these high-margin AI chips, especially HBM. And what happens when supply for everything else dwindles? Prices for consumer DDR5 and NAND have just gone through the roof. We're talking prices that have tripled, sometimes even more, in a shockingly short amount of time.
So it really just boils down to money talks, doesn't it? The big players with deep pockets are calling the shots. That brings me to the GPU cloud squeeze. How bad is this for small AI companies, the startups trying to innovate, who don't have Microsoft or Google's budgets?
Oh, it's very bad, Michael. Honestly, it's creating an almost insurmountable barrier. Companies like Microsoft Azure, AWS, Google Cloud, they're naturally going to prioritize their internal teams first. Think about OpenAI, for instance, a huge Microsoft partner. They're getting preferential treatment, massive prepaid contracts that secure their access to thousands, even tens of thousands of GPUs. For a startup, even a well-funded one, trying to get access to these same resources, it's a nightmare. They're facing year-long waits just to get allocation, if they get it at all. Prices are up 30% or more on top of already expensive services. And then you've got these huge minimum order requirements. It's essentially creating a two-tier system. The big players get guaranteed stable access, while everyone else, the smaller innovators, are left scrambling for scraps or just priced out entirely.
That's just brutal. It really stifles innovation if only the behemoths can afford to play. From a purely technical standpoint, Randy, what's the reason HBM and GPUs are so crucial for AI, and why can't smaller teams compete on that volume?
It's all about the nature of AI workloads, specifically machine learning and deep learning. They rely heavily on parallel processing, especially massive matrix multiplications. GPUs with their thousands of smaller cores are inherently designed for this kind of parallel computation, and HBM, it's the perfect companion. It provides incredibly high bandwidth. Think of it as a super wide, super fast highway for data to move between the GPU and its memory. This is critical because AI models are huge and they process massive data sets. You need to feed that GPU with data as fast as it can crunch numbers. If the memory is slow, the GPU sits idle and you lose efficiency. Big contracts guarantee not just revenue for the cloud providers, but also incredibly high utilization rates for their expensive hardware. A small team might only need a few GPUs for a short period, which is less appealing than a multi-year contract for thousands of units, ensuring those pricey HBM-equipped GPUs are running at 90% plus capacity around the clock. The economics just don't favor the small, agile players right now.
That makes perfect sense, and it paints a pretty bleak picture for the little guys. Shifting gears a bit, we've been hearing these almost dystopian stories about laptop refurbishers literally ripping RAM out of old machines to resell it. Is that actually real, or is it just industry hyperbole?
No, Michael, it's absolutely real. It's not hyperbole at all. The cost of new DDR4 and DDR5 modules, especially in bulk, has become so prohibitive that for many businesses, it's more economical to harvest memory from decommissioned systems. Think about a big corporation upgrading thousands of laptops or desktops. Those old machines, which might have gone straight to recycling before, now become valuable mines for RAM. You're even seeing it happen with old store display units or even just general e-waste. Companies are specifically targeting machines with decent amounts of DDR4 or DDR5. The used memory market is booming. And while it helps some smaller players get by, it's also paradoxically accelerating the e-waste problem. Instead of these components being reused in a whole system, they're being stripped, often less efficiently, for just one part. It's a short-term solution to a long-term problem.
The thought of someone tearing apart a perfectly good, albeit old laptop just for its memory, it really highlights the desperation. What about the SD card side of things then? Is that related to the same memory crunch?
Absolutely. It's the same underlying issue, just a different form factor. SD cards like SSDs use NAND flash memory, and just like DRAM, NAND flash is being heavily diverted to enterprise-grade data center SSDs. These are the super fast, high-capacity drives that underpin all those AI cloud services we just talked about. They need vast amounts of reliable, high-performance storage.
So what happens? Companies like Micron, through their Crucial brand, have essentially exited the consumer NAND market for SD cards. Sony has suspended orders for many of their consumer-focused SD and CF Express cards, limiting supply significantly. Other manufacturers are now prioritizing only their most premium, high-margin professional cards, leaving the everyday consumer, the casual photographer, the drone enthusiast, with fewer options and significantly higher prices. We're talking consumer SD card prices up 100 to 200% or more, which is just insane for something that was once a commodity. So if you're a photographer or videographer, or even just someone trying to expand your phone storage, you're getting hit hard. It's not just the high-end AI labs, it's affecting everyone down to the consumer level. Randy, with all these price hikes, how high are RAM and SSD prices going to go, and how long do you anticipate this situation lasting?
Well, for DRAM, we've already seen increases of 50% to over 300% on some modules, depending on the type and supplier. SSDs have similarly doubled or tripled in price. The general consensus from industry analysts and the manufacturers themselves is that this tight supply isn't going away anytime soon. We're looking at this extending well into 2027, possibly even beyond. The reason is that building new fabrication plants, new fabs for memory is incredibly expensive and time-consuming. It takes years, literally, from breaking ground to full-scale production. And even as new capacity slowly comes online, the demand from AI isn't slowing down. AI is still projected to take up a staggering 60 to 70% of the total memory output for the foreseeable future. So while new fabs might ease the consumer side a tiny bit, the vast majority of new memory will still be hoovered up by AI data centers. It's not a temporary blip, it's a fundamental shift in market dynamics.
Wow. 2027 is a long way off. That's a serious timeline for market disruption. It sounds pretty grim, Randy, but is there any silver lining to all of this? Any positives that might come out of this crunch?
Yes, absolutely. There is a silver lining, though it requires a shift in perspective. This memory crunch, in a way, is forcing innovation and efficiency. When resources are abundant, you can be a bit wasteful with your code, your models, your infrastructure. But when memory is scarce and expensive, it forces developers and researchers to be incredibly efficient. We're seeing a huge push towards smaller AI models, which require less memory to run. There's also a big focus on better quantization techniques. This is essentially reducing the precision of the numbers used in AI calculations. For example, going from 32-bit floating point numbers to 8-bit integers, which drastically cuts down on memory requirements and computational load, often with minimal loss in accuracy. We're also seeing renewed interest in CPU inference, especially for smaller models or specific tasks, because sometimes a highly optimized CPU can still be very efficient. And perhaps most importantly, it's pushing for smarter software. Developers are learning to optimize their pipelines, manage memory more intelligently, and explore entirely new architectures that are less memory intensive. So while it's incredibly painful for small players and consumers in the short term, in the long term, this scarcity could lead to a healthier, more optimized, and more sustainable AI ecosystem. We might end up with AI models that are faster, smaller, and more efficient overall, which is a good thing for everyone eventually.
That's a really hopeful perspective, actually. It's like necessity is the mother of invention, right? What advice do you have for our listeners, whether they're small business owners, developers, or even just consumers looking to upgrade their tech, on how to navigate this Ramagedon?
My primary advice would be to optimize now. If you're working with AI models, don't wait. Look into model compression techniques, better quantization, and ensuring your code is as memory efficient as possible. For consumers or small businesses looking to buy hardware, if you can, buy ahead. If you know you'll need a new laptop with specific RAM or an SSD in 6 months, consider buying it now because prices are likely to only go up. Keep a very close eye on the used and refurbished markets. As we discussed, there are still deals to be found there, though with caveats. Our practices independent to be affordable. There isn't ever working a tub with measurement many. Instead of traditionally Yoli training or 5, we calling something like a bit farming measure site. And for those needing GPU access but can't stomach the cloud prices, explore decentralized GPU options. There are platforms emerging that allow you to rent idle GPUs from individuals or smaller data centers, often at more competitive rates. It's not always as reliable as the big cloud providers, but it can be a lifesaver for smaller projects. Ultimately, Michael, money talks. Today, it's undeniable. But efficiency and smart resource management are absolutely going to win tomorrow. Those who adapt quickest will be the ones who survive and thrive.
That's fantastic advice, Randy. Optimize, buy ahead, watch the used market, and explore decentralized options. Really practical takeaways for everyone listening. It's a challenging time, but clearly there are ways to adapt and even innovate through it. Thank you so much for breaking down Ramagedon for us, providing such clear and fair technical answers. It's been incredibly insightful. And to our listeners, what's your Ramagedon workaround? Are you optimizing your models? Are you scavenging for old memory? Drop us a line and let us know your strategies. Thanks for tuning in to Byte Sized AI. Stay efficient, stay innovative, and we'll catch you next time.